So we want to practice some skills on evaluating expressions or evaluating using algebraic evaluation. But before we work with equations some more, let's complicate things on expressions. That way we're keeping it a little bit simpler so you can develop the process that you need. And the name of the process that we're going to use is substitution. So you've probably heard substitution before, especially in a math class, but we want to be a little bit more explicit about what that means. We want to have an exact understanding of what substitution means. And we'll start with a basic problem, a little bit like the ones we worked on yesterday. So we want to evaluate 18 minus x when x equals 7. Now remember, yesterday, for our previous lesson, we were able to not put in the word when and replace it instead with a semicolon. Both work just fine. It's just important that you know what the semicolon means and what the when means. All right, so let's go ahead and evaluate this. What this means is I want to know what does this expression, just the 18 minus x, equal if instead of x I put a 7. So I'm going to write 18 minus, I put parentheses right around the x, it helps me keep myself organized, and then I can plug the 7 straight in. And so 18 take away 7 equals 11. So that's all there is to it, just evaluating an expression. It'd be lovely if all expressions were simple like that, but they are not, so let's look at a couple more complicated ones. So this is clearly more complicated. I have 2x plus y when x equals 2 and y equals 6. Now I have two substitutions to make. So the first substitution, I'm going to use yellow parentheses around the x, and the second substitution I'm going to use blue parentheses around the x. And now I can just rewrite my expression, but making sure that I leave enough room to make the substitution. So now just double checking I have exactly the same thing. 2 times whatever's in the yellow plus whatever's in the blue. Great. Now let's put, well, we had an x here, but we know that x and 2 are equal to each other. That means what used to be x is allowed to be 2 because they're exactly the same thing. I'm just trading out exactly the same value. Same thing with y. I'm going to put in a 6 for the blue where I used to have a y. I'm now going to put in the 6. And now I can just do some arithmetic on it, or some order of operations, and multiply my 2 times 2, which equals 4, and add to that 6 and then 10. So let's do this one now. Again, a double substitution, same trick. I'm going to put yellow parentheses around m, and I'm going to put green parentheses around n. And now just rewrite the whole thing, leaving room for substitutions. Okay, so I've written exactly the same thing. 4 times, check it out, that would have been an m, plus n cubed. So I can just go ahead and put my values in. All I have to do is be sure that I put the right one in the right place. So the yellow parenthesis is an m, so I'm going to put in a 7. The green parenthesis was n, so I'm going to trade it with the 10. And now I can just figure out what these are. Well, 4 times 7 is 28. And I want to add to that 10 cubed. Well, 10 cubed is the same as 10 times 10 times 10. Well, we know about multiplying tens that you just keep the 1 and add the zeros. So I have 1 with 3 zeros. So that's 1,000. So that would be 1,028. And that's it.